Hello, this is Shula from shulatutoring.com, and in today's video we will balance this redox equation using half reaction method. We will follow 11 steps that are listed here on the right side, and we will get that done. So the first step is assign oxidation states. I've done this already, and you see there are oxidation states written above each atom in each molecule. If you need more explanation on how to do that, I'm attaching a link to the video that I made a few days ago, and it explains how to assign oxidation states. And actually, every single one of those molecules is in that video. So please take a look at that. And in the meantime, we are continuing, right? So this is done. Number 2, identify reduction and oxidation. So reduction and oxidation mean that you are either gaining or losing electrons. So in each case, whether it's reduction or oxidation number or oxidation state has to change. So let's take a look here. Let's take, for example, chlorine. Right? Chlorine has a number of -1 here on the reactant side, and it has -1 here on the product side. Right? So nothing really changed for chlorine. But if we look at, for example, iron has an oxidation state of +2 on this side, and on the other side, on the product side, the number is +3. So there was a change there, and our oxidation state increased. And an increase in oxidation state is oxidation, because we are becoming more positive. The only way it can happen is if we lose electrons, right? Because electrons are negatively charged. And if we lose electrons, we are becoming more positive or less negative, right? So any of those changes is oxidation. So let's look more. For potassium, it's +1 and +1, right? So no change. But for manganese, right, so on this side we have +7, and on the other side we have +2. So what happened to our oxidation state? Our oxidation state decreased. So a decrease in oxidation state is reduction, because we are gaining electrons, and if you gain electrons, you gain negative charge, so you become more negative, or you become more positive, or you become less positive, right? Like that's one way to look at it, right? So +7 to +2, you are becoming less positive or more negative. So that's reduction. And so we've done that. Now we need to separate reaction into 2 half reactions. So we basically separate this reaction into oxidation part and reduction part. So let's do that. So this is the first one, oxidation. When you do that, make sure you leave a lot of room on the product side and on the reactant side, because we will have to add a lot of things there. Right, so this is our first one, and then the second one is this one on this side, and then manganese chloride on the other side. Okay, so we did that. Now we need to balance atoms other than hydrogen and oxygen. Okay, so for this particular part, the only atoms that are not balanced are chlorines, right? So we have 3 chlorines on this side and 2 chlorines on that side. So what I'll do, I will add HCl. And this is how I will balance chlorines. My hydrogens are not balanced, right? But that's fine because specifically this particular step is balancing atoms other than hydrogen and oxygen, so that's fine. For this particular one, we have potassium on this side and no potassium here, so I will add potassium chloride. So let's see what else. We have manganese, right? We have potassium, and but we don't have chlorine on this side. So I will add HCl again. But let's see how many HCl's do we need to add. We have 3 chlorines on this side, right? 2 from manganese chloride and 1 from potassium chloride. So we need to add 3 HCl's to make up for that. Okay, so now I think we are done with number 4. Number 5, balance oxygen with water. Okay, so for the oxidation part, we don't have any oxygens to balance, right? So we can continue. For this part, we have 4 oxygens on this side, no oxygens on this side. So let's add 4 molecules of water, right? Because each molecule of water contains 1 oxygen. So to make up for 4 oxygens, we need to add 4 molecules of water. Done. Now balance hydrogen with H+. So here we have 1 hydrogen, here we have none, so I'll add H+ to the side. Let's see here. It's a little bit more complicated because here we have 8 hydrogens, right? And here we have 3 hydrogens. So let's add 5 hydrogens. And you see I'm already running out of space, happens every single time. Yeah, so I've done that. What I wanted to mention is that I have 11 steps here, and at first glance it might seem like a lot of steps, but once you start doing that, you see that it goes fairly quickly. And the next step is balancing charges with electrons. All we have to do, we have to calculate excess charge. So for example, on this side, I have iron chloride that's neutral, and I have hydrochloric acid that's neutral, right? So the overall charge on this side of the equation is 0. How about this side? I have a neutral molecule, and then I have 1 plus charge, right? So I have plus charge, 1 plus charge on the product side, and 0 charge on the reactant side. So what do I have to do? I have to add 1 electron to this side, right? And then what happens? I have 0 on both sides, and it's balanced. For this particular equation, all the molecules on the product side are neutral, and I have an excess of 5 positive charges on the reactant side. So I will add 5 electrons to this side. So I've done that. Now I need to multiply reactions to have the same number of electrons. So I have 1 electron in this reaction, and I have 5 electrons in this reaction. So what I need to do, I need to multiply 1 reaction or both reactions in a way that I have the same number of electrons in both reactions. So the simplest thing to do is to multiply this whole reaction by 5. So I'll do that, and then I'll just rewrite both reactions. So I have 5. Everything gets multiplied by 5. So coefficients will change, but what's it called? But subscripts don't change, right? So don't make this mistake, please. Don't change any subscripts, just multiply coefficients. If there is no coefficient in front of something in a chemical reaction, we assume that the coefficient is 1, right? And 1 multiplied by 5 is 5, obviously. And the other reaction just remains unchanged, right? Which is we are just it just stays the way it is. So just need to copy it down so that we could work with it. So we are getting to the end of our balancing problem. Okay, so multiple reactions to have the same number of electrons. We've done that. Now, cross out the same atoms, molecules, and or electrons on opposite sides of the reactions. This is the fun part. That's the part that I really like. So what does it mean on opposite sides? So this is the reactant side. This is the product side, right? So this side would be opposite from this side. So what do I have that's the same? I have 5 H plus ions and 5 H plus ions here. I have 5 electrons here and I have 5 electrons here. Do I have anything else that's the same on opposite sides? No. Right, so what I can do now, I can put check mark here, and now I can add the reactions together and simplify. So that's what I will do. And I will try to keep the same order just so that you could see how the reaction changed, right? So I have 5 iron 2 chloride plus potassium permanganate, did not change, plus what? Well, here we have 5 HCl, right? And here we have 3. So we are adding the sides of the reactants in both equations. So I'm adding them together. I'm simplifying. So now I get 8 HCl, and that's it for that side. I get 5 iron 3 chloride plus potassium chloride plus manganese chloride plus 4 H2O. Like, it's very important for this part to just not forget anything, because so many mistakes happen because people just forget to copy something down or something like that. So just be careful, because you're dealing with a lot of different things here. So we've done that, and we just have one final step that will show us whether what we did was correct. And that final step is to check that we did it correctly. All right, so we need to verify that we have the same number of atoms on each side of the equation. So let's start with iron. I have 5 irons here and 5 irons here, right? So that's correct. I have 1 atom of potassium here, 1 here. Okay, great. 1 manganese here, 1 manganese there. In terms of chloride, so let's see. 5 times 2 is, what is 10, right? And then I have 8 chlorines here. So I have 18 total here on this side. 5 times 3 is 15. So 15 plus 2 plus 1. So again, 18 on this side, 18 on the other side. In terms of oxygen, I have 4 oxygens here, 4 oxygens here. Great. And now finally hydrogen, 8 hydrogens here and 8 hydrogens here. Perfect, right? So I think we did it correctly. Don't skip this last step. It's important. If you made some mistakes, it will show, and you'll be able to track your mistakes somewhere. Like, you know, if you, let's say, have a mismatch in the number of atoms other than oxygen or hydrogen, you know that you did something wrong here, for example, right? So just make sure that you verify that your reaction is balanced. Don't skip the step, it's important. And I think we did it. So thank you for watching this video. And if you have any ideas or any requests for me to make some specific videos, please let me know. I'll be coming out with more videos about different topics in biology and chemistry. So please give me a like and subscribe so that you don't miss any future content. And hopefully I'll see you in the next video.